Hello friends, this is Fahad from Game Code Bytes. In this presentation, I'm going to show you how to build a particle system to simulate Big Bang using JavaScript. So let's get started. I created a basic boilerplate for this project, a folder called Big Bang, and then within that folder, three files: index.html, index.js, and style.css. Index.html to have the canvas element, create a canvas element to draw things on it, and a reference to the index.js file. Index.js file where we will create all of the logic for the Big Bang simulation, and style.css to style some things in the HTML page. And the index.js file, we have some basic logic here, getting a reference to the canvas and the context to draw on the canvas, setting up the width and the height, and centering the canvas in the middle of the page. And that's it. Before we touch the code, let's just think about what we want to do exactly. Every time we refresh the simulation or start the simulation, we want to have a bunch of particles that do some sort of an explosion from a singular point. For example, the middle of the screen. You start the simulation and then you'll see a bunch of particles exploding on every direction. So let's do that. I'll start with creating a class called particle. And you can think about this particle as every single piece in the explosion. So this explosion is going to have a bunch of particles. And just for a change, I'll use a class instead of a normal function with JavaScript. So particle. And we will pass the X and Y position for that particle, and also we'll pass a color. And I also need to create a randomized direction. Let's say math.pi by 2. And I'm also going to create a velocity. And the velocity is going to be the x component of that direction we just created. And the y component, the y velocity is going to be the y component of the direction. And then we also need a speed. Let's just randomize it as well. Now probably this is not a very good random function. We can create our own function, and by setting, and when I say creating our own function, random function, it's because we need to set minimum and maximum value, but it doesn't matter. We'll skip this for now. And I also want to encapsulate everything within this class. So we need, for example, a render function within the class instead of doing it separately to render this particle. And we need to pass the context. And then we can simply draw a rectangle or square. Also, we'll create an update function. And this update function is going to update the position on the x and y axes by the velocity of that particle and multiply it by the speed. We'll do the same on the y axis. Okay. Now we need to create a general update and render function for the whole simulation. And then within that update and render, we will update and render all of the particles. So I'll say function update. But before that, we also need to create a particles array to hold all of the particles within it. And then we will loop through all of the particles. We can just use for each. And then here we'll call p.update, particle.update. And we can do the same in the render. So we'll create a function called render. And we need to pass the context for each particle. And lastly, we need a frame function. And that frame function is going to request animation, the animation frame, and send the frame itself as a callback. And here we'll say update, then render. And also we need to clear the context within the render function. Now we need to create some particles. So I'm just going to loop through a number, let's say 200. And let's go up and create a constant called particles num. And let's use 200. Particles num. And then use that here. And then we'll just push some particles into the particles array. So I'll say particles dot push new particle, and let's just start with width divided by 2 and height divided by 2, and the color maybe orange. Okay, now let's just call the frame function to start the simulation. Now we're not seeing anything. We don't have errors. We also did not create a width and height properties for the particles. So I'll say this.width equals math.random, and let's say 7 or maybe 8. And then the height is going to be exactly as the width, so we can create squares. Let's test this out. Nice. Now every time you repeat the simulation, you will see this Big Bang simulation effect. Now this is nice, but why don't we just use more than one color instead of the orange color only? And to do that, we need to randomize the color prop in the particle instead of just using one color, which is the orange we're passing here. But before that, let's create a colors array. Then I'll pass a bunch of colors, orange, then maybe cyan, something like blue, and maybe yellow. Then we'll keep the class as is, but here, and just for clarity, so you can read it more clearly, I'll just create a color here and say colors of math.random. Actually, we need the math.round at first, and then the random multiplied by the colors.length. And then I'll pass the color here. Let's test it out. And it's working. Now let's add something else. The moment that particle goes outside of the canvas, we want to reset that particle to the middle of the screen. We can either do it in the particle, or we can do it in the update function here. Whatever you want. Let's just do it here, for example. So I'll say if p.x less than 0 or p.x greater than the width, or, and it should be almost the same logic here for the y. I want to reset the particle. So I'll say p.x equals width divided by 2. p.y equals height divided by 2. Let's test it out. And it's working. You can even create a reset function. And within that reset function, you will add some new values to the particle. For example, updating its velocity, randomize the velocity on both x and y axes one more time, and maybe change the color as well. But you're getting the idea. Now let's try and tweak some of those values and see how the simulation will behave. For example, we'll use more than 200 particle, let's say 1000, and maybe add a new color, red, and also increase the size, the maximum size to 12, and the speed to 7. And let's see what's going to happen. And it's working. Let's try to increase the size, the width and height of the canvas. 420, 560. It's working perfectly. Alright friends, this is going to be the end of the Big Bang simulation with JavaScript. If you like this one, subscribe to my channel and stay tuned for the next video. Thank you guys for watching. This is Fahad from Game Code Bytes.